Okay, here we've got a question about this curve where x and y are all entangled. It's an implicitly defined function. First thing we've got to do is show that when x is 1, a, in other words the y coordinate, is 1. So you just simply substitute in for your x value the one that you know, and you solve a quadratic equation for y, and you use the fact that a is greater than 0 to select the correct solution, which will be 1. Then we need the gradient of the curve at P, which of course is dy by dx. So we've got to find dy by dx from this curve here, so we've got to differentiate. And because it's implicitly defined, we need to use implicit differentiation. So the only term that's just straight ordinary differentiation is that one. This, where you've got a function of y, differentiating y with respect to x is fairly straightforward anyway. Or you can differentiate y with respect to y and get 1, and then multiply by dy by dx. That's how you do implicit differentiation. Check your notes for details. And then this one here is a product. So you have your u and your v, and you differentiate u normally, and you differentiate v using implicit differentiation, and you set up an equation with dy by dx in it. At which point you may as well substitute in the x you know is 1, and the y you know is a, which is also 1, put in 1 for x and y, solve the dy by dx, and get your value, which will give you 7 marks. And then finally we've got to get an equation for the tangent to the curve at P, and as long as you've got an answer for what dy by dx is, if this is followed through, you've probably got a re-entry point here, because we've got a gradient and we've got a point, so you just use your core 1 recipe for getting the equation of a line. It's a tangent, so dy by dx will give you the gradient of the tangent, and you're done.